Good morning, guys. Some familiar faces again. guys, good morning. Setting. Guys, how many people is there? Recap of the story and guys that were not in class. I've just went with the guys that weren't Well, this is about some differences. So when I see some people there in class. So I see some nice job we were rerunning. It was a class. Yeah, no problem. Will be about no classes. Yeah, it was good. I see it's the same crew. It's the same crew. I see some new guys here coming. I see it.
first test to the last flight, these jet engines are always under close supervision.
Oh,
Good morning, Jorge.
good morning, Shani. How are you?
I'm doing well. How are you doing?
Pretty good. How was your
Excellent.
weekend?
Yes, yes. Do you have a good weekend?
Yeah.
Excellent, excellent. I'm going to go ahead and hand the class over to you. If you need anything, just go ahead and let me know.
All right, I'll do.
Thank you. Okay,
Thank you.
guys, you are unmuted. If you need anything, you know where to find me.
All right. Thank you.
Yo.
Good morning, guys.
Morning.
How was your weekend? Did you get to work over the weekend?
No.
No? So that was good news. Okay, I see a few more of your partners in this class that were in the last week presentation, as I believe. So this week I was asked to cover the differences of the 777-200 versus the 300. Unfortunately, I can say regarding differences, there are not too many. But what I was assigned was changed a little bit because I decided that maybe I will talk about differences between these passenger planes and the freighters, which are there are more features to discuss. Also, GE90 will be presented. This is the alternate choice of engine for this same plane. So as you will see, these are really similar designs. One thing is that the engine is the same, but the differences are based on the way they install some of the components on each engine. So we will see those, but in general, you will see that they work just about the same. They put different names on them regarding the components, but they are really similar. I think I will present, just to recap, a couple of videos for the new guys that were in the previous class about how this engine, that is not the engine, but the airplane was designed at first. And also we will present some features about the story of the making of the engine. Later on, we will see some slides, black and white papers, that will let you know about these features. So this is mild class, so to speak. There won't be any questions. So this is just to present you how many differences you will see, and I guess to have a good time just watching videos and staying away from the everyday job. So let's start with the first video. Let me just bring it up there. I'm still loading a couple of videos, but shouldn't take too long. Just give me a second to bring them up. All right. Okay, so the first one is the story of the Boeing 777
has been a
All right, so here we go.
The 777 has been a great success for Boeing and is the company's best-selling wide-body to date. It was launched in 1994 and is now entering its third generation with the new 777X. Developed as a clean sheet design in the 90s, it was designed to capitalize on the improvements in twin-engine performance. This idea is taken further as the 777X becomes the largest twin-jet aircraft ever to fly. Let's take an in-depth look at the story of the Boeing 777 in today's video. The Boeing 777 came about as a new aircraft to fill the gap between the 767 and the 747. By the 1980s, Boeing had developed a solid lineup of aircraft. The Boeing 737 had become the dominant short-haul aircraft, and it offered a variety of longer-range aircraft, the 757, 767, and the 747. The 747 was the top choice for long-haul routes, with twin-engine aircraft previously limited in operation. This changed with the introduction of ETOPS rules, with twin jets able to operate further from a diversion airport. Restrictions were changed in 1985, and the first ETOPS 120 flight was with a TWA Boeing 767 from Boston to Paris. This allowed for routes up to 120 minutes from a diversion airport. The change in regulations opened up transatlantic routes to the 767 and even the 757. Just as the 747 had changed airline economics with its high-capacity offering, this changed things again with more efficient, lower operating cost aircraft serving longer routes. The 767 worked well for lower capacity routes and allowed new routes to be launched, but there was a gap in the market now for a twin-engine aircraft with higher capacity. Airbus took advantage of this with its joint A330 and A340 project. The A330 was the largest twin-engine yet when it was completed in 1992. It was not long, though, before the 777 was launched and took over. Boeing originally proposed upgrading the 767 to serve this market. The 767X would offer a stretched fuselage and larger wings. But airlines rejected this, wanting a wider fuselage and improved operating costs, leading to a new clean sheet design. Boeing launched the 777 project in 1989, with the first aircraft flying in 1994 and entering service in 1995. The 777 was developed in close collaboration with 8 airlines: All Nippon Airways, American Airlines, British Airways, Cathay Pacific, Delta Airlines, Pan Airlines, United Airlines, and Qantas. All except Qantas went on to order the aircraft. This collaboration established the capacity and other specifications to be used and ideal variations. US Airlines, for example, preferred a shorter fuselage aircraft, while others, including ANA, wanted longer, and British Airways, among others, wanted a longer range version. These preferences were all reflected in the initial 777 design. The 777 was Boeing's first aircraft to rely heavily on computer design during development. While there were some initial mock-ups, Boeing later claimed that it was the first aircraft that, quote, didn't need its kinks worked out on an expensive physical mock-up plane. Construction took place at Boeing's Everett facility. There was a significant expansion to add 2 new production lines. All wide bodies before the 787 were built there. It was notable, though, for subcontracting large amounts of work to other companies, including to international suppliers. This concept was taken much further later on with Boeing's next clean sheet design, the 787. Parts manufactured were smaller and easier to transport than they would be for the 787, where entire composite fuselage sections and the wing are built overseas, requiring the use of the Boeing Dreamlifters for transport. For the original 777, construction took place in several countries. In Japan, Mitsubishi Heavy Industries and Kawasaki Heavy Industries built fuselage panels. Fuji Heavy Industries was tasked with the aircraft center wing section. Over in Australia, Aerospace Technologies of Australia built the rudder, and Hawker de Havilland the elevators. Boeing later acquired both these companies. The first 777 was unveiled in April 1994 and made its first flight on June 12th. This original 777, the 777-200, was the smaller of two variants, designed to meet the needs of US airlines. It entered service with United Airlines and operated its first commercial flight on June 7, 1995. Over the next 3 years, Boeing launched two more variants. Overall, the three first-generation or classic variants are as follows. The 777-200, which was the initial shorter variant, this entered service in 1995 with United Airlines. There was the 777-200ER, which offered increased range and payload. This entered service with British Airways in February 1997. The 777-300 featured a stretched fuselage with an additional 10 meters. This entered service with Cathay Pacific in May 1998. By 1997, 777 orders had risen to 323 aircraft from 25 airlines. It was already well on the way to being a strong success for Boeing. Boeing always had the intention to increase the range of the 777. Early proposals looked at shortening the -200 to develop a lower capacity but higher range variant, similar to what was done for the 747 SP. This was dropped, though, in favor of keeping the capacity. In the late 1990s, Boeing began the development of these next generation of 777 aircraft. Of course, they kept commonality with the same fuselage and cockpit design, but also increased the wingspan by almost 4 meters. Engines were also switched to the newly developed GE90 engines, thus there was no longer a choice of engines as with the first generation. The first aircraft to be developed from this generation was the 777-300ER. This entered service in 2004 and would combine the size of the 777-300 with the range of the 777-200ER by increasing the maximum takeoff weight. The fuselage and landing gear were also strengthened. This matched the long-haul needs of many airlines, and the 777-300ER has gone on to be the most sold 777 variant. The 777-300ER was joined by the ultra-long-range 777-200LR in 2006. This kept the length of the 777-200, but used the same improvements as the -300ER to allow increased weight. With additional fuel tanks, it extended the range to almost 16,000 kilometers. It entered service with Pakistan International Airlines in 2006. It has not been a great success, with only 60 aircraft delivered. Its main problem was, in fact, too much range. It achieved its range through extra fuel. This made it heavy and expensive to operate on long routes. As part of this second generation, Boeing launched the 777F freighter model. This took advantage of the upgraded engines and increased MTOW to carry freight payload. Critically, its maximum payload was only slightly lower than that of the 747-200F, 104 tons compared to 110 tons, so it made a good choice for retiring older Boeing freighters. The 777 and 747 together have ensured Boeing continued dominance in the freighter market. There is a chance for Airbus to challenge this dominance with its A350 freighter. In terms of orders, the Airbus rival seems to be off to a good start. The 777 story is far from over, with the 777X now being tested and due to enter service in the coming years. This will be the largest and highest capacity twin-engine aircraft to date. The 777X was first proposed in 2011 with a targeting flying date of 2018 as a larger, more efficient successor to the 777-300ER. It keeps a lot in common with the previous 777 family members and introduces some key new features. Most importantly, it retains the same metal fuselage construction. The Boeing 787 and the A350 are clean sheet designs that have introduced composite fuselage construction to reduce overall weight significantly. The 777X has the same fuselage but has increased its width by around 4 inches through thinner walls and more efficient insulation. If all goes according to plan, there will be two versions of the 777X, the 777-9 and the smaller 777-8. The 777-9, the first to launch, offers a capacity of up to 426 in a two-class configuration. With a length of 76 meters, it is the longest commercial jet to date. The smaller 777-8, if or when it gets built, will offer a capacity of around 384. The smaller 777-8 will compete well against the A350-1000, but the 777-9 is really in a twin-engine category of its own and takes the capacity of twins much closer to quad jets. Despite its commonality with earlier 777 types, there is a lot to be excited about with the 777X. It'll achieve more efficient operation, but with high capacity and range with new engines and larger wings. When it comes to new engines, it'll feature the largest and most powerful to date. The new General Electric GE90X engine features carbon fiber construction and fewer fan blades to reduce weight despite the larger size. After several delays, the GE9X engines finally received FAA certification in September 2020. There are also folding wingtips. The larger wings on the 777X are critical for its performance and efficiency, but large wings can cause operational problems at many airports, a problem faced by the A380. The 777X wingtips fold on the ground, reducing its wingspan by around 5 meters. This keeps it in a lower aerodrome category and expands its operating possibilities. There have been several setbacks to the development of the 777X. There were initial delays due to engine issues and structural testing, and further delays have been incurred due to the slowdown during the pandemic. Boeing's original plan was to have it in airline service by 2021, but this continues to change. The aircraft is currently undergoing test flights. In January 2021, Boeing stated it would not deliver the first jet until late 2023. In an interview with Simple Flying in April 2021, Emirates President Sir Tim Clark referred to the Boeing 777X program being in a state of disarray, indicating delivery could be as late as 2025. The current estimate at the time of this video's production sees the aircraft entering service in early 2025. Of course, there's always a chance that this could change again in the future. On January 31st, 2022, Boeing announced that it would be offering a 777X freighter. Last year, it was expected that this variant would enter service in 2027. Lufthansa and Qatar Airways are the main customers for this cargo jet thus far. The full story of the 777X could still change. While only the two passenger variants have so far been confirmed, there is the possibility of more for the 777 family. A possible further stretch to a 777-10X would take passenger capacity up to around 450. Nothing has been confirmed by Boeing as it aims to focus on getting the Dash 9 into service. Such a stretch technically should not be too difficult, but the decision will undoubtedly depend on airline demand and whether Airbus revisits the idea of an A350 stretch. With well over 2,200 orders to date, the Boeing 777 has been the most successful wide-body. But we're only just seeing the start of its next generation, with plenty of life left in it. So what do you think of the Boeing 777? What are some notable flights you've taken with this aircraft type? Share your experiences by leaving a comment down below. Simple Flying publishes over 150 articles every week. If you're looking for the latest
Jack.
So how do you enjoy that one? It's been incredibly popular, and even though it's been some time since they rolled out this plane, it's been in the market and it's still doing great things for us. I believe it's really trouble-free, including the engines, regarding which one we are working on. So my experience personally was on the GE engine more than the Rolls, because we had only uh, freighter operations in Mexico. The only planes that I remember that came with this arrangement, I believe, were some charters. They eventually came over here with British Airways. In most cases, we only have GE90s and GE9s with Alitalia and the Emirates fleet as well. I believe I will have another presentation regarding this development regarding as per the orders in the Arab countries. Um, Also, there is another um, story about the differences between this plane and the 300, and this is just to let us know why this is the 300 is not so popular. They designed the version of an extended range plane, and this next video will explain what is the fact that one of them weren't so popular, so everybody's picking the extended range version instead. So I have it right here. So here we go.
The Boeing 777 has been a huge success for Boeing. Since the type's launch, it has overtaken the 747 to become the most sold wide-body in history. And the aircraft's legacy will continue into the future, with the new 777X promising a lot. But amongst the variants, the non-ER 777-300 stands out with low sales of just 60 aircraft. So why exactly was this the case? The 777 was developed as a long-range twin jet to capitalize on the improvements in twin-engine operations possible with new ETOPS regulations. The 747 had already seen huge success as a long-range wide-body, but with higher capacity and 4 engines. The 767 had success as a smaller capacity twin jet. Boeing saw big potential with something between the two. The 777-200 entered service in June 1995 with United Airlines and proved a popular choice with several US carriers for domestic flights, and was also popular in Asia. The strongest demand, though, was for a longer range version. With a range of 9,700 kilometers, the 777-200 was limited in its ability to perform transoceanic operations. The 777-200ER addressed this with an increased range of 13,080 kilometers. This variant entered service with British Airways in February 1997. Order numbers show the -200ER's popularity, with 422 deliveries compared to just 88 for the 777-200. The same situation with strong demand for a higher range has been seen with the larger 777-300. This larger airframe increased passenger capacity by around 20% to around 368 across 3 classes. The non-ER 777-300 was launched at the Paris Air Show in 1995 and entered service in 1998 with Cathay Pacific. With a range of 11,165 kilometers, this variant offered a good step up from the 777-200 in both capacity and range. The 777-300ER didn't enter service until 2004, but the aircraft has sold quite well since then, with its extended range of 13,649 kilometers. Just as was seen with the 777-200ER, this is the combination that worked for more airlines. For flexible long-haul use, many airlines wanted a higher range. At this end of capacity, many airlines were looking to replace their 747s, and the 777-300 just did not offer enough range to allow them to do that, while the 777-300ER did. The popularity difference has been huge. The Dash 300 has seen just 60 aircraft built and delivered, while the Dash 300ER has seen 822 deliveries. Put simply, nothing was wrong with the 777-300, improving on the 777-200 airframe and adding more capacity. This variant worked well on shorter routes, just as the 777-200 had, particularly in Asia, where many airlines had concentrations of high-capacity, medium-haul routes. Cathay Pacific, Thai Airways, Japan Airlines, and ANA have all used the non-ER 777-300. ANA even operated the Dash 300 with 514 seats on key routes, while Emirates also operated the type on similar profile services. However, Boeing's offering of an extended range Dash 300 unlocked long-distance routes for legacy carriers looking to efficiently transport large volumes of passengers, which is why so many airlines have been more attracted to this variant than the standard Dash 300. This capability will continue into the future with the even more efficient 777-9X. Well, just as soon as Boeing can get it certified and into service. Have you ever flown on a non-ER 777-300? Did you even know there was a difference? Let us know in the comments. In addition to our daily YouTube videos, Simple Flying publishes over
So how do you like this one, guys? It's interesting, don't you think? How many airplanes of this type are usually coming into the Ascent MRO? Have you ever worked on them yet?
Yes.
Yeah. Okay. Do you get passenger configs or freighters?
Passenger.
Passengers. Okay, so this presentation will be a good head start for you as you see what differences are there in the freighters. Disregarding that there are no seats, so no complaints about IFE or any seats issues. I also have another one that will describe differences, particularly found on 200s and 300s, but this one was obtained from the database of the Boeing, where they produce these CVTs. But I think I need to download it from the other computer. So let's see. Well, it's not in this drive, but I'll find it. Anyway, before we go through that, let me show you what we are going to cover during this couple of days. And here it is. Okay, so well, they didn't send me the study guide or the presentation as it was in the other class, but what we are going to show is the Boeing 777 freighter, just the avionic portion, part of it. Also, I like to talk about the manual set for this airplane, so you get used about how this works, you know, how to handle information in case you are working without any task cards. I know MROs usually based their assignments producing task cards, but in this case I'd like to comment a little bit about how the job is done in the line when manuals are used. If you ever worked in the line, you're familiar with this set of books, but I just wanted to present this as a reminder for you to refresh your minds about how they do in the line every day or overnight flights. This is a setting. We have several manuals. One is called what they refer as a maintenance planning document. Also, there are on schedule maintenance manuals. One of them is a flight full reporting manual. The flight reporting manual is from pilots, but in case of maintenance, we have the full reporting manual, which is also referred as a FRM. Next one is the full isolation manual. Then we have the structural repair manual. Obviously, there's an airplane maintenance manual. We have the dispatch deviation guide, and the supporting data comes in the system schematics and the wirings and the IPCs. The first of them, it is used to produce specific checks, and I think all the task cards that you are assigned to work with comes from this maintenance planning document. So you will find the tasks like transit checks, or they also call through stops, also turnaround checks, daily checks, and I'm sure you are familiar with ABC checks as well. So engineering is responsible to produce this task, and they are obtained from this document. So it will give you a list of things that you have to do as per on time limiting inspections. So you start with the transit check, and maybe the overnight that will be also included and is not listed here. The weekly checks also can be found here if we go really into deep in this manual. So they are based in time terms. So it's just to make sure that the airplane is not going to stop for lack of servicing between flights when it is not assigned for a heavier maintenance check. So that's one of them. The on schedule maintenance manuals, they refer to things that happen that the ICAS will communicate that could possibly affect the serviceability of the flight. So as you know, the FRM is usually used by pilots as well, and they will give you a precise location and a precise description of the problem by accessing some code numbers. So when we cross-check those numbers with the maintenance page's existing codes, the code that is presented in the computer will be transferred into a language understandable for technicians, so we can cross-check that number with the fault. So instead of having a database that describes as a whole fault name, it just tells us the numbers. So the number will produce a drop-down window if we're transferring that into the computer, and the drop-down menu will let us know what is exactly the problem, and also will give you a hint about the problem and how to approach to it in order to fix it. So also full isolation manual will tell you what tests can be done. And for that purpose, we have in this engine, in this airplane, uh, the feature that is common to the newer planes that is called maintenance access terminal. We talked a little bit about that last week. And for the guys that weren't in the class, with the maintenance access terminal is just a computer that is set on board plane that will allow to access the technical info. So we can have access to uh, information without having to go to the hangar and retrieve it from a different manual. So everything is on board. There are no paper manuals, no hard copies on board. So it's only MAT and its database that will contain specifically the full isolation manual. I have you bring some laptop or any means of information if another type of tests need to be recorded. So that would be contained in the AMM. But the most important manual that we will use on this type of airplane is the full isolation manual. So MAT will contain a lot of tests, will give you what components are associated to some specific problems, and even it describes the module identifiers. So you just cross match whatever it is telling that it needs to be repaired. And also there's a structural damage, which is a separate manual. And this is usually there just to assist in locating affected damages, affected areas with damages in the fuselage or the wings. So this will give us the instructions to isolate the areas in the drawing, so we can tell the engineering department details about what is the precise location of certain damaged area. As you know, the structure is not the same, so you could find panels of certain type and certain thickness that are installed in the forward side of the fuselage. And maybe as you go through the back, the structures will be modified. So the strength and the thickness of the skins of the fuselage might be different. So that's important to know that this structural repair manual will let us know as we find the exact location of a damaged part, what is exactly the panel number, so the engineer can retrieve information or produce instructions to patch a problem or to inspect any dents or any damages that were found. So that's the purpose of the structural repair manual, just to locate damages along the fuselage. This is also not on board, but in case you are able to release a flight that goes for the transit line operations, in order to let the plane to go to a different station where maybe there is enough support as for tooling or manpower. They use this DDG, the dispatch deviation guide, also called MEL, minimum equipment list. And this book is like a Bible for us in the line. So it will tell you which is the minimum equipment that we can have operative in order to allow the flight to continue without any disruption. So anything that is not contained here regarding a fault means most of the time that the airplane cannot be dispatched. And then once we have a problem, the airplane is sitting in a suitable place that we can work on the problem. Any component replacements can be tracked and it can be done through the AMM. We are aware of it. It will provide instructions about specifics on each subsystem, so we can have them replaced. Also, to locate anything on board, there is this IPC which will let us know exactly where it is located, and it'll give us the proper assembly number so we don't miss it. The wiring diagram, well, it's good for avionics guys. Whenever a hardware problem occurs within the system, maybe something is faulty at times, so intermittent faults cannot be really tracked during the transit flights. We will get this wiring diagram to assist us in locating what are the power sources, and just in that way we can track if the power supply is being correctly sent and received by the component. We can get exactly where connectors are located and so on. The system schematics, they are like initial reference for the wiring diagram. So the wiring diagram will give us a specific numbers, will tell us about the wiring gauges and the power values, and the schematics are only describing in general where these components located in the airplane with no so without this the same detail as what is found in the wiring diagram. Another thing that is important to remember is that if we establish priorities, in the old days, we know that the airplane maintenance manual was the one with the highest one, and this is not true anymore. It is not shown in here, but there's something that should be should be listed or should be drawn in this slide, that is pertaining the temporary revisions. Temporary revisions, as you know, are just changes that were made to the airplane systems, and they produce a document that will supersede some specific sections or pages within any of the manuals. But they produce them and will not be incorporated until all of the fleets around the world are updated with the fresh information. So they produce the single page for all the operators, and once it is published, the operator should have a book that will be on board, and that will be used to tell the maintenance personnel about changes that will be incorporated in the maintenance or full isolation manuals or the structural manuals. So we have to check that listing first in order to see if the affected system that we have is incorporating any changes in procedures or any changes in parts. So before we go through the maintenance manual, especially hard copies, we need to check for these updates. Even Matt, whether they tell us the newer version of the manuals when changes happen, because it has a loadable database. So somebody in the hangar will be responsible to come with the floppy disk and fit the computer with the changes. But if we do not have the airplane at that moment, and we are just checking, and this is just an example, we're expecting a plane and we're checking what kind of a fault we will need to go through, because the airplane already sent a message informing it of a problem. We will start retrieving the basic information in our desk. But firstly, we need to go and check if there are temporary revisions made to this associated problem. So in general, this is the set of manuals that we have for the line operations. So I wanted to refresh knowledge just about this one, so you are aware that these many manuals will be very useful when we come back to the line. So about this section, that's about what I can tell you about, guys. So let's take 10 minutes for coffee time or something, and I'll present another couple of videos before we go to the next section. Engine, we have an extended document available in the server. It will not be covered in its entire, I think. There is more information that is needed. This manual is produced by the instructors that probably are teaching B1, B2 classes. So normally this book is taught in 2 weeks, because it's a complete information, so it goes into more details than what the GenFam could show. But again, we'll have anything that you want to consult in case you are really interested to know about some more specific things on this engine. So be back in 10 minutes, guys, and we'll continue on with this.
Yeah. Doing that right now? Yeah. Yes. Volví a la pero realmente estaba llena de agua, güey. Estaba flotando. Y no daño. Oye, pero eso no es nada. Porque todo es algo viejo de todo. Y lo voy a llevar a la es una marcha que solo la marcha que veo que quiero. ¿Cuál marcha? You know, I was too. ¿Cómo pongo una marcha? A lo mejor pensé que no estaba degollada, porque nada más ve la estaría con la pelota. Mira. ¿Pero cómo va a girar? Si no va a proyectar con la pelota. Como dices también, ¿cómo te va a Pancho, ya a lo mejor le metieron otra mano. Se la va a girar. ¿El corrido del motor? ¿Según dice igual? No, no sé. Según dice que le dijo mal. La marcha, o sea, que le empezó a preguntar, oye, si apenas la máquina, vamos. Pero es cuando te no sé. Que le dijo, no, sí, es que abrimos la máquina, no quiero. Es que te fuiste de toda la vuelta. Una vez que sacamos la punta de la flecha. Pues sí, así fue lo que le dije, iban en Chile, a ver cómo. Sí. Claro, ¿no? Entonces, no, pues es que oye, la misión, la guardo. Pero que no se vea por pregunta, usted estaba de arriba. Estaba de arriba. Le hubiera dicho, a ver, abre la mano. Pero cuando la corrieron la segunda vez, yo me acerqué. Y sí se sentía que giraba, me acuerdo. Y el ducto sí se sentía el aire como.
Sí, sí se escuchaba, ¿verdad? Que giraba,
Ajá.
digo,
Estaba
con él y se escuchaba cómo giraba. Le digo, pues es que se escucha cómo gira, pero no está girando en dedo.
Exacto.
Porque empezamos el auto de hasta abajo.
Yo personalmente también toqué el ducto y le salió bien el ducto. Está caliente, está pasando. Si yo estuviera abriendo la válvula, el ducto va a estar arriba. Pero si se calentaba el ducto, ustedes sintieron que se sabe. O sea, que estaba a lugar de la pero la otra necesidad. Sabrina dice, no, es que ya lo tiraron. Hay que tratar de cuidarlo. Si le pusieron una marcha de otro motor, que no es esa. Sí, pero si pusieron la marcha. Cuando está por lo que le decía yo. Pero que sabes que son, no, es que si le doy la marcha normal y lo gira. Y a ver cómo lo gira, pues si no tiene marcha. ¿Cómo lo gira si no tiene marcha? De no, pues es que le pusieron la marcha. Pues para la marcha, pues está en buenas. Le voy a estar en ¿cómo le pusieron la marcha así? Pero es que no sé, es el chiste que me dijo raro. No, pasen el reporte porque no. Vas a estar chuleando ahí. Sí, yo también. Sí, cayó, no así. Pues es que ya me quiero que. Quiero que me quede la cara. Así es esto del abarrote. También sábado y domingo, sí. Nada el domingo. Que ver en plano lo que vamos a nosotros no bailar. Entonces, siguiente, luego mañana acercarnos ya temprano para ver que hoy cómo va a estar la dicha. Se supone que la lucha es más gente, pero que estamos en que descendió. Lo de los patrones de la Skype ya se hoy llega uno y mañana llega el otro. Del normal. Vamos a ver. Expectativas para que vean. Pues se supone, ahorita nosotros estamos haciendo los cálculos antes de venir para acá. Bueno, no, ya lo hemos empezado a usar. No sé, ya hablar. Todo eso hacemos nuestros números. La proyección de pegando los motores y otros días más. Por ahí del 19 de febrero del 23. Hay que subir motores y hacer operaciones. Subir esos motores, hay que cargar protección para todos los tanques. Hay que hacer los side runs para las cubas de todo el mundo, pues hacer las operacionales, cerrar lo que falta. Las operaciones todavía, las instrucciones del motor, tareas de instrucciones. Ellos aplicarse con eso. Aviones para los pendientes. Y el weight balance, el weight balance, que va a hacer la protección para el weight balance. Hay que hacer el Kiswin, FPAs, tal vez. Pero sí, hay que echarle por eso de atrás, hay que echarle por eso. Hay que decir, si no lo echamos una vez, se puede ir. Estaba haciendo, pues tiene un poquito. No está completamente vacío. No nos va a faltar para se suele decir, pues igual, pues le echamos combustible que no sé para llenar un agua. Llenamos esa ala, ponemos el otro motor opuesto para que le comprese el peso ahí. Entonces, que penetrados, eso es lo que vamos a estar con el motor. Ya si está listo el motor, ya pegamos la conexión. Vamos un ala, esa se queda hasta el día siguiente, no hay fugas, la pasamos al otro. Abrieron tanques. Y aparte de la otro, decían que iba a llegar, pues, bueno, se supone que es 30. Yo llego un de Chile, 67. 67. Esto lo va a agarrar, digo que Ada o Chare. Ellos son los que traen gente con curso. Sí. Es una causa de ¿cuál es para el DH? ¿Cuál es el que? ¿Es el DH? Bueno, eso es nada más un líquido. Es líquido. Ah, sí, claro, también. Eso es más de el IENTA. No sé si quieres. Igual, si se ofrece, pues si no podemos hacerlo nosotros. No, es el paz. Al suelo, al derecho. Segundo, para endoscopía. Dice, llamar es una alarma. Llamar al seguro para la endoscopía. Sí, pues sí, hay chamba. Y luego decía, hombre, decía, es viernes, ahora que vimos para el economía. Empezar a que las personas los que están ahí, pero no sé, porque son que tomamos, vamos a tener un social, vamos a emplear todo eso, que te ves, no, por la hincha es esperado que no puedo ser prepararnos para lo que tenemos que 3:30, luego 1:37, y luego agarrar eso que por sentar tu vamos a poner las palas para darse impacto. Y está chido, pero pues, yo también soy de la idea como de no querer así, querer abarcar tanto, ¿no? Sí, con calientes, es que tenemos que buscar como que no se luche, tal vez un tercero, con la idea de que no tenemos que estar fue la cosa, digo, la niña pues es pega, podemos agarrar otro y la línea no quitamos, estamos de cristal, tenemos el yo, o super proyectito después de si tú quieres agarrar esa página, va a estar quedando todo. Y en un tips es mucho. Algo que está olvidando ahí tú.
Tampoco. No he sido luz de. No, es la alarma de las 8. De la misma tierra, correcto.
Según sí dice aquí que el motor llega hoy y mañana.
Pero de hoy y mañana.
O sea, uno llega hoy y
Ajá.
el otro llega mañana. A ver qué dice ahorita en el transcurso del día. Estoy en bonita aquí. Si bien 37 kilómetros. Te mágicamente listo. Todos son muy similares. Pues llevan la parte de adelante, la de atrás para los techos. Y acá. Eso. Quiero la dicha que va a quedar más tarde. Y lo vamos a dejar que saben más.
Pero en heavy location, y tú quieres.
Lo vamos a dejar. Matamos el verse para bajar el señal, el center body, o meterle la fruta de probarse. Y si de eso le dije a Rano, y si eso que Rano, pues te dijo que hay que hacer un nuevo final y para que Rano es hora se puede quitar esto. Pero se trata con el frente, desde el celular, muy así es, pero es chido. Que quitar esto, pues está manda por separado, con los guardas aquí. Hey, Dave, what's going on? You were late today.
No, I just wasn't early, not as early. You got to hear like, huh? 2 minutes still or something?
Yeah, definitely. You're like,
I usually get here early, but I usually get up early. I was tired last night. I couldn't sleep. Just wanted to be better today. They had to make sure that, they were able to, they're gonna do a procedure.
¿pero qué dice? Sí, con el.
I think they're gonna do it tomorrow.
That's great.
They're gonna schedule a biventricular pacemaker. I'm gonna put a pacemaker.
Hola. ¿Sigo? ¿No? ¿Qué onda? ¿No?
Yeah, Coke also all week at the same time. So we're having heart problems. So.
¿Te arreglaron tu pasaporte? Eso. ¿Ya lo traes, mamá? Sí. Pues todo después. No. O sea, igual, esta última vez que lo grabé fue en Ciudad de México. También, igual, fuimos todos. Fuimos a trámites, dice. Y de la visa igual, la visa, lo vimos. También me dijo esto. No, no quieres, ¿no? Porque entendió que es el domingo. Pues vente a Carlito por yo. Yo sé que a la espalda. Y nos quedamos, y pues sí nos quedamos, pero pues, como andamos ahí haciendo tiempo, hicimos tiempo de más. Ya pues, cuando llegamos a la oficina ya estaba cerrado. No, no quiero presentar, no, es que me llaman, o sea, y horas con 4:10, 4:15. Bueno, ¿cómo que listo a las 4? No, pues a las 4. Listo a las 4. Interviews. No, qué bárbaro. Ahí les playa. Demoramos ahí para irnos a los planes que traían. Como quieran, no agarramos nada. Y luego regresando de la playa, pues, otra vez ahí, a poder recibir la vista. No.
Okay, guys, are you back? Can we continue? Okay. What I'm going to present this time is the specific differences as described in the Boeing CVT presentation regarding the 200 and 300 versions only. It's not regarding any freighter information at this point. So let me show it to you.
What?
Yeah. Yeah.
The 777-300 airplane is a high-capacity stretch version of the 777-200. The fuselage is 33 feet or 10 meters longer for a total length of 242 feet 4 inches or 73.8 meters. The maximum weights for the -300 vary depending on engine thrust and customer options. Here are some typical weights. The flap limit speeds for the -300 are also different from the -200 and IGW airplanes. The engines are generally more powerful and each produce at least 90,000 pounds of takeoff thrust. The 777-300 is designed for routes up to 5,600 nautical miles or 10,370 kilometers. This map shows the typical range capability. The extended fuselage allows for additional seating and cargo space. 328 passengers can be accommodated in a 3-class configuration, and up to 550 seats are available with an all-economy configuration seating 10 abreast. 2 overwing doors have been added to accommodate the additional passenger load. The door numbers have been resequenced so the doors 3 left and 3 right are now over the wing. Let's look at the differences in the overwing doors. The escape slides for the overwing doors are located in the wing-to-body fairing. If the escape slide door is not closed and locked, an ICAS advisory message displays. When doors 3 left or 3 right are open, the spoilers on the associated wing automatically stow in the down position for escape slide extension. The overwing slides are not rafts and should not be deployed in the event of a water landing. Door 3 left or 3 right may contain a separate life raft for ditching, depending on airline configuration. If a raft is installed, the respective door must be opened with the door mode select lever in the disarm or manual position to prevent slide deployment. As with the other doors, the evacuation slide automatically deploys when the passenger door is opened with the door mode select lever in the armed or automatic position. Open the overwing door number 3 left. Only the first part of the escape slide can be seen from the passenger door. An inflated barber pole is the visual indication that the remaining portion of the slide has inflated and is ready for use. If the slide fails to inflate automatically, a manual inflation handle is located in the upper aft portion of the door sill. To operate the manual inflation handle, pull down the cover. Pulling this handle inflates the slide manually. The 777-300 airplane has the same fuel system as the -200 IGW airplane. The entire center tank wing box contains fuel. The left, right, and center tanks contain a total of 302,900 pounds or 137,500 kilograms of fuel. As with the -200 airplane, the fuel jettison system will jettison fuel from all tanks at the same time. However, main tank jettison can be delayed under certain conditions. When the airplane is heavy and loaded near the forward CG, fuel is jettisoned from the center tank first. This is to keep the CG within limits. The computed jettison time is automatically adjusted to reflect the increased jettison time if main tank jettison is delayed. The 777-300 is equipped with a tail skid. The tail skid retracts and extends along with the landing gear and is connected to the center hydraulic system. If the tail skid position disagrees with the landing gear lever position, the ICAS advisory message tail skid appears. The flight crew for the 777-300 airplane sits more than 100 feet in front of the main landing gear wheels. A ground maneuver camera system helps the flight crew to determine taxiway and runway edge clearances during ground operations. Cameras are located in the leading edge of the stabilizer. These provide a direct view of the left and right main gear wheels during taxi. Note the stripes painted on the top of the wing. These stripes are placed directly over the outside edge of the main gear wheels to assist the pilot in locating the main gear wheels in adverse lighting conditions. The system automatically compensates for stabilizer position changes to keep the main gear in view at all times. The nose landing gear camera is located on the underside of the fuselage aft of the nose gear. All of the camera windows have window heat to prevent the formation of ice, frost, or condensation from The ground maneuver camera display can be viewed on any multifunction display. A camera display switch has been added to the display select panel. A camera display switch has also been added to the display select panel control page for use if the display select panel fails. Use either switch now to display the camera on the lower center MFD. All three camera views are displayed at once as a split-screen color display on the selected MFD. The nose gear view is on the upper portion of the display. These are the main landing gear camera displays. The camera view can be especially helpful when making a 180-degree turn on the runway. The turning radius for the 777-300 has increased to 182 feet. Lights on the wings illuminate the main landing gear during night operations. The lights are located on the outboard flap support fairings. The light for the nose gear camera is installed on the aft side of the nose gear strut. Ground maneuver camera lights are turned on by this switch on the overhead panel. The camera lights are designed to be used during taxi operations. The lights will not illuminate unless the beacon is also on. Turn on the beacon. Now, turn on the camera lights. As on the 777-200, the current Mach number is digitally displayed below the airspeed tape when the current Mach number is greater than 0.40. However, on the 777-300, when Mach is less than 0.40, ground speed is displayed. When a transition occurs between the display of Mach and ground speed, the new display is highlighted for 10 seconds.
So as for 200 and 300 differences, that's all it is there to say. So next video that I will show, let's see, it's regarding of the making of this GE engine. But before we go through that, let me introduce some of the features for the engine. So this is GE90 engine. So we will talk about the generals first. Okay, so as I said, this manual was produced by the British Airways School, and it is referring to the GE90. So we will see some of the differences as they have been increasing power on later models. So first of all, we know that it supplies the airplane thrust through all phases of flight. It is also high bypass ratio turbofan engine, and we use also this engine to supply the electric, the hydraulic, and the pneumatic systems. The information of the layout in the manual will present it as usual in this way. So we'll start with the section 71 and then 72 and so on. So we will get to all of the controls, like the engine fuel and control, then the engine controls indicating oil starting, air and ignition and exhaust. Throughout the time we do the presentation, you can also consult some of the acronyms that are listed in this manual too. And well, again, these are the sections that made up this engine. What about the hazard areas? Well, just bear in mind that this plane has, this engine is a high power rating, so you gotta be cautious when it is operating and you are in prox vicinity. So there are certain places where you can go, like for checking leaks or some specific points that you need to do on the engine while it is running. So it is showing here what is the entry corridor section that you need to observe. Now, if the engine is idling, you have to be away more than 53 meters or 175 feet when you are standing behind the airplane. If they use breakaway power, then the distance is increased, so you have to move for about over 200 meters or over 670 feet. But if it is really using full power, you can feel the blast if you are still standing at as far as 640 meters or 2,100 feet. So I know you're not going to be sitting there unless you are risking your bones in San Martin. You know, that airport, you remember, people go there just to grab on a fence and feel the engine power. Maybe I'll bring a video just to let you know how people gets there to have fun with the engine power. All right, so anyway, well, just for introduction, we will show what are the exterior panels, the cowlings. So just like with the Trent engine, it is made of 3 sections, so you can open the segments individually. Also, there is the PDO's assistance just to ease the opening and closing of any of these cowlings. So this is what you see when you approach to the engine. So it is arranged in this way. So there's an inlet cowl, we have the span cowl, the thrust reverser cowl, and the turbine exhaust. So there's a segment which is called the primary nozzle, then there's a forward center body and the aft center body. And these axes that are also removed when necessary are called thumbnail fairing, the forward axis fairing, fairing 2, the aft side fairing, and the fairing number 3. So these panels are also removable. The PDOS actuation and control switches It is just describing other components that are attached here. So in the first part, the inlet cowl is where the T12 sensor is installed. Also, the engine anti-ice system is there. The power door opening system actuation also. The control switches are there, and there are some hoist points available. The engine anti-ice system, the supply duct is at 11 o'clock on the inlet cowl, and the exhaust air of the EAI is at 7. So here is the supply, and here is not listed, it's not shown, but exhaust should be around here. There's an access panel if you need to remove the T12 sensor, and the PDOS electrical connection will be found on the right side too. The hoist points, whenever there is a chance. Oh, first, this is the an opposite or an opposed view of this cowling. So it is showing where the EAI duct exhaust is located. And PDOS switches are also here. So we have a set of switches for each of the cowlings. If you need to remove the inlet cowl, there are provisions. So you can come with your sling, and when you attach it, then you can use a hoist to take it off. This is also the sling attachment location. So you can remove the entire cowling by holding it by these holes here. If the cowling is not removed, but it's just open, you will find this found cowl opening actuator and the hole open rods. So actually, this is what is driven by the PDOS, and this is what hold this to hold the cowling open or closed. So those rods are standard. If you were in the Trent class, you will see that they are just about the same. This is a view of how the cowling latches look like, side view. So there are 4 that you will find below the engine. And there's a quick release pin that you can take off if you are assigned to remove the cowling from the engine. So there's one per hinge. Sorry, not inch, hinge. Hold open rods. Well, same thing. They have yellow stripes and red stripes. If any red stripe is visible somewhere here, means that this lock is not properly secured. So you have to make sure that you push this locking collars in order to make sure that the red band disappears. Now, the next one shows where to attach the sling to the thrust reverser half when you remove them. There are 6 hinges, and you take also some pins off the assembly so you can detach the entire half. Okay, now there are some more latches also involved, and this is the view looking up if you are under the engine. So this is the arrangement. You still have to open some accesses in order to get to these latches. Also, on the forward section of this assembly, you will find what they call the T-bolt latch handle. And it looks like this if you take a closer look. So there's a sequence that we need to follow in order to open these halves. That is because sometimes if you don't follow the sequence, it will be impossible to open it because it will be holding one segment because the other side is loose, so it has to be done the other way around. So there are some numbers that are painted on the surfaces that will guide you through arrows about where to start and where is the last to be opened. And then when you close, you just reverse in the same way. The whole open rods for the reverser, they are typical. Also, yellow and red stripes will be visible. Turbine exhaust, well, that's a typical, and you can see that the rear frame has some locks where these links can be attached. So it is called the primary nozzle. This vent tube extension is typical to all GE engines. So they paint the gearbox and the oil system from here. So all of the fumes will be noticed in here. So it is pretty normal when the engine is shut down after a flight that it will produce fumes in here. It is just relieving trapped air as the oil gets cooled. And this cone that surrounds the vent tube extension is just called the aft center body. Okay, this is a typical installation of these latches, and if they need to be retightened, adjust them. You just make sure that the latch handle, especially that, comes to a flush position. There's an L-inch range that you can use, so you drive it in or out in order to give tension to the latch. And they are also typical to any GE installation. GE F6 engines have the same type of latches. So you just make sure that one end will come in through this keeper, and this latch handle embraces it, so the handle itself will be flush. So it is supposed to be a little loose. There's some slack here between flush and what you see in the image, where it might be a little loose, and then you apply pressure and you really remove this latch from the keeper. All right, so this is another view of the same thing. In this type of latches, in order to adjust this latch, you just need to do a turning of this wheel in order to increased the length or reduced it. So it catches the mating part here. So any adjustments that are required are made just through driving this little knot here. This is an adjuster. All right, so this is the PDOS, the power door opening system. So the opening can be done by only one person, and so that's why PDOS is there for. So you can use this self-contained unit, so it doesn't have a relation to any system in terms of sharing fluids. So it has this its own reservoir, which is this square type box, and this is a pump, and there are a set of 5 solenoids that will drive the oil through the actuators, so you can open and close. So the controls are located on both sides of the engine. They are mounted between 7 and I believe 4, and they are flushed. So they are identified because they are circled by red paint. They are powered by the 28-volt DC ground handling bus. And there's a set of switches also for this thrust reverser actuation. But the same PDOS it is related to also the thrust reverser halves. So there's only one power pack, but there are switches to control the opening and closing of the half reversers and the engine cowls on both sides. So this is a type of actuator, nothing new. They just receive power here to extend or retract. Actually, when you retract, we don't need this to bring them back to closed. You just hold on the switch and it will drive one of the solenoids, so it'll let pressure just to go out. Problem is that when you are trying to close and you use this gravity, if those halves would not come to a flat position against the matching side, chances are that you will have to come up to the engine pylon, remove that cover, and press the proper solenoid to let the remaining oil to exit the actuator. It happens from time to time. So just make sure that you know if you need to open, you have to have somebody there to drive the motor with a manual speed drive tool, or if you are going to close them and it is not closing, you still have to come up there and push any of the appropriate solenoid valves to release or relieve the trapped fluid. I think I've been through that like 3 or 4 times, but it's generally working fine. It doesn't really give us a problem. Okay, so now this is another view. This is the thrust reverser cowl opening actuator. It is right there here, one on each side. The pump power pack would look like this, so meaning the cover that is here have to be removed, so you actually have to slide part of this fairing in order to get to that. So is not an easy job, especially because there are no flat surfaces here. So you have to be secured with some sort of a harness, or you have to bring some special ladder so you can get access safely to actuate this PDOS. This is a thrust reverser and cowling opening switch. So you see it is here, and also the opposite side is here. So you can find first the ones that will open the thrust reverser, the engine cowling surface first, and then once it is open, the next switch will be inside. No relation to any switch in the flight deck is present, meaning that you just come release the latches. So you start with the cowling latches, and then you will actuate the motor. So we'll drive one at a time. And then when you are ready, you continue on latching. Now, yes, in sequence, the remaining latches as described by the paint and arrows. So once everything is been released, all these latches are off, then you hit those buttons here, and then the reverser hatch will open, and this will be the same. They will sit on the hold open rods, and you have to actually lift them a little bit, and you have a guy with a ladder to step up and release the lock rings, and he will have to hold it for a bit. So when this downslide motion is passing the locks of the hold open rod on each side, you can stop. Then you remove these steps, and then you can continue bringing those halves all the way down. Same thing happens. You open these cowlings, so you have to when they are secured and sitting on the rods, you have to press the actuators a little bit more just to relieve the tension on the rods, and then the guy with the high steps will release the locking sleeve and will hold it until the cowling goes down a little bit more, and then you release it, and then he can exit the area, and the gravity will do the job. So the same thing happens on the other side, but still you have to press these switches in order to actuate these solenoids. Well, power plant. I guess this is good information for you, as you are usually related to removing engines when you are in assignment for a job repair. Sorry. So you have to use some dynamometers. So you need to monitor them on the forward and aft hoists. So you make sure the loads are less than 15,000 pounds or 18 kilograms on the forward outboard dynamometer, or this other value, which is 11,000 pounds or 5,000 kilograms on the forward inboard dynamometer, and 4,000 pounds or 18 kilograms on the aft dynamometer. So if the loads are more than the load limits given, the engine can fall and cause injuries to persons and damage. I believe there is an example that I can show you later about what happens and how could you see if that happens, which is pretty bad. So I believe I need to get some, yeah, I can show you. You give me a minute. So let me look for this picture real quick. No, it's not here. I'll save it for a future moment. So let me continue. I have to. I just recall that I have these pictures, but I need to get the other USB. All right. So anyway, I promise I'll show you. Anyway, this is where you come with your bootstrap assembly, and you have to accommodate it right here.
We're not seeing. We are
Oh,
not.
you don't see it?
Yeah.
There you go. Okay, so this is the after bootstrap assembly. You can see where you can comment and attach it in order to bring it to the engine throttle. The forward bootstrap assembly is installed here, and where is the other part? Forward boost. You have to understand. Okay, so the dynamometers, these are the ones, are installed here. So this will tell you if the process is conducted evenly. So you don't bring one section, the upside or the forward side down at a higher speed, and it is holding more weight than the opposite side. So you have to keep that within the range as described in the previous slide. You can check it out on your presentation, where you can track you can keep track of the values that you have to need to observe. So obviously there are specific instructions to remove this engine from its support. But in general, you have to connect the bootstraps in these sections, meaning I have to take them off, take these engines off evenly. So you could think that maybe the forward side is heavier, but it's not. The core is really heavy. Remember, the idea of the whole design of an engine is to have a bigger fan, the biggest fan possible, and the smaller core and the smaller high pressure compressor section. So they are trying to bring as much air through the fan passage than from the core. So what happens is that the core is made really with heavy materials. So that's why this part should be a little more heavier than the forward side. Now this part comes back to the thrust reverser, and it just shows how these actuators look if you take a side view of the engine. So they are just actuators. They are supplied with pressure from the PDOS system, and when you have to bring them down again, they just release pressure without any pump action. So the only feed line is here. So it pressurizes to extend, or by gravity, all of the contained oil in this actuator will be pumped out back to the tank. And the whole open rod is here, this one. So this is where the collar sleeve will show you if the reverser is actually sitting on its slug or not. So obviously, if you see a red stripe here and you release that control switch for PDOS, it will not hold. So it will tend to go down again. So you have to bring it up high enough in order to bypass this red stripe and get the yellow marks to show. All right, so yes, that's if you are intending to disconnect the engine, well, we have to see this picture, and it'll tell you what you have to remove. If you look up here, there's a big rope latch band, and also there are some electrical connectors that need to be disconnected, like IDG terminal block. There are some core strut electrical connectors, and that also need to be disconnected. Also, the core strut and hydraulic hose connections must be removed first. So it shows where to locate them. So you actually have to come up here. You will get to see all of this, which is expanded in this side of the slide. So you remove all these cables and hoses, and once the hoist are connected, and you have removed also the upper starter ducts and the pneumatic ducts that are related to the pneumatic system distribution from the HP and the IP connections, and then you can start taking this engine off. So you come to the right side. It looks the same, has another big rub latch band. There might be some additional connectors that you will find. There's a fan cowl hydraulic flex hoses, fuel spray blanket is there too, and the PRSOB and fan valve will be on the other side. So I'm sure you're really aware of what are the main actions you should take when you are taking one of these engines off. So the procedure is pretty standard, regardless of the plane. So you just need to make sure that you follow all this, considering that there are a bunch of connectors and hoses that need to be removed from the connectors and contactors before you can take it off. Guys, let's take another 10 minutes, and I need to find these videos that I was referring about. So because they are really related. At first, on the first picture that I wanted to show is somewhere in one of my memories here in my USBs. So I'll get it ready when you come back. So please take 10 minutes and we continue.
Pregúntale, Clayito, ahorita.
This is actually a 340, and it's more like to me. It looks.
¿Estás sangrando, no mames? Exacto. Vamos, pero si le digo, vamos a pregunta de primero. Me está diciendo, ¿me acuerdo? Bien. Porque que agarrabas. No, güey, no. Pues, la licencia de la licencia. Mira, ahí no le creas, güey. Yo quería preguntar a Pacho si le dio, güey. Me dice que no, no creo todo lo que sí. ¿Sabes? Es que ayer me dijo, güey. Dije que con el Pacho, güey.
Take it at the same time.
Yeah, that's what I was hoping. Where do you go? Oh, I don't know. What? You left. Huh? Or. You gotta go to the floor. Oh. After his appointment, we still have a meeting. That week, January. Oh. I'll talk. Yeah. Let's shit, I hold a couple of hours, man. Till payday, I don't get paid till the 30. To the 30? Yeah.
A esos albañiles se lo...
You go to scan your sentence. You don't. Should be more secure. Not full secure. Got that too. Well. What's the way to wash clothes that are soaking in a. What they call
A pesar de que hay agua ahorita en los baños, la presión no es adecuada. No está alcanzando a subir a los tinacos. Esto lo tenemos desde el día viernes identificado. Pero en las noches, por algún tiempo determinado, como que le han de abrir a toda la válvula y entra con más presión, porque ya también identifiqué que hay tinacos que sí amanecen con un buen nivel de carga, pero probablemente no está llenando lo suficiente a todos. Yo creo que eso ha de ocurrir un solo momento, un par de horas, han de abrir bien la válvula y vuelven a reducir el nivel de agua. Pero por certeza tuya, quédate tranquilo, Jorge, yo ahorita reviso tus tinacos y te confirmo cualquier cosa. De todos modos, ya tengo pedido una pipa. Ese es otro problema, también te lo platico. Si ahorita en la revisión estás con desabasto, te voy a revisar tu departamento, eso te despreocupa. Pero en lo general, el servicio de las pipas me lo van a prestar hasta las 12 del día. Va a estar medio complicado también. Ahí te mantendré al tanto, pero te comparto. Si ustedes llegaran a tener desabasto y todavía no llego ya a la Torre 5, tranquilo, con mucho gusto les hago cargo.
Sí, nada más digo. Para eso, el hoy, continúa. Ahorita voy. Está haciendo 33. Esa era la anterior matrícula. ¿Cuánto te ponemos? Pero la voy con Jason ya o en el otro. Sí, sí, está bien. Sí, luego atrás, no, la primera puerta, no. No. Sí, ahí. Debe estar ahí en la costa. Y no estarían en el punto 11. Ya contigo, con tu oficina. Y yo creo que debe estar en tu oficina, ¿no? Lo más seguro. Pero es que está escaneada, es eso lo que me parece. Ya. Entonces, sí, bueno, digo, porque como ya están escaneadas, creo que ya es, pues ellas los cuando hay un feedback, nomás lo pone ahí sus papelitos y ya. En este caso, que ya hay. Estas son de 4 de la mañana. Hecha. Pues saliendo así. Bueno, no, entonces voy con el chico, lo espero, si no está, no, te los acompaño.
Uno más largo, unos pocos más. Alright, guys, I'm back. Alright, guys. Next, bootstrap equipment. Bootstrap. Let's prepare. This is a bootstrap. ¿Cómo se llama? Se me volvió a perder. Okay, guys, so I'm back. I found those pictures I was telling you about. So here they are. Well, this is not related to what we need to know at this moment, but yeah, it was a little mishap here. Here, this is what could happen if something is wrong. Obviously, this is not a GE engine, but same thing happens. I believe this is a 340 plane. So they didn't observe the procedures, so something was wrong with the forward side. And yep,
The chains failed.
it happened like that, so it was not properly removed. This is courtesy of Qatar guys. So this is a very rare picture because information from Arab countries is really limited. So I guess I was lucky to get this picture. He was taking a Qatar. All right, so probably you've seen this one. He just missed the runway, I guess.
No, from what I remember, that happened in Memphis. They were doing tests and the brakes failed on the airplane.
Oh, I see.
Alex Benicio was injured on that.
Yeah. Always, anything I touch, always break.
I believe it happened the same. I just recall of one event on 340. I don't know if it was for also Qatar, happened to Emirates, some airline in the Arab countries. They were also testing one plane at high power setting, and they did something wrong with the circuit breakers switching. So the brakes released and the airplane just hit a wall. Probably I have a picture I'll show you. When you get to see it, probably you will remember that it happened long time ago, a long time ago as well. What about this one? Do you recall of this event as well?
Boom.
We do that every day here.
Yeah.
That looks like it's here.
3 weeks ago.
Yeah, he was right. Going really close to this one. I'm not sure if this is 747. Might be by the shape of the wingtip. Obviously, this is a Ilyushin or a Tupolev plane, which he comes from. He was in Russia, I guess. So you can see it here. This assembly is familiar to the Russian planes. Probably there is some antenna installed up here, but anyway, it happened. This one is well known. I'm sure you have seen that a lot of times. So it was also true. It happened to, I'm not sure what was the plane, the company involved. It was Airbus. And well, they ditched this plane. Have you ever seen this one?
That wasn't Sully, was it? No. In the Hudson.
Well, anyway, it happened. So, okay, the main actor in this slide is the engine failure. So remember, if you don't follow procedures, this could happen. All right, so if we continue, these are the bootstrap assemblies. You are really familiar with them. This is where the dynamometers will be found. So you have to observe that the tensions are equal when you are lifting or lowering these assemblies. And they will attach to the forward attached fittings and the aft attached fittings will accommodate here. So mounts, this is the aft engine mount, and this is also the forward mount. This is what you have to remove here. You have to detach this part in order to secure the engine to the hoists and the straps. And if you come to the forward side, then you have to install those straps in here. So there are only forward nav mounts in this way. Okay, so this plane comes with a bunch of drain lines, so the drain mast will be the bottom part of the engine and will look like this. So you have a set of lines that will let you know what is the origin of a leak, what is the source of leak, because those lines are, as usual, look tied to certain components. So all these lines are bringing fluid over here. Well, this is just like a maintenance tip. It says that, for instance, there are 6 system tests and 10 special functions for each engine. So those tests can be run through MAT. So you can check the fuel-driven actuator, air-driven actuator, the ignition system, the reverse thrust reverse lever interlock actuator test check. Also, you can check for presence of any debris in the oil system. And also you can check and test the electronic engine control. These are system tests, and also there are what they call special functions. You will see that special wet motoring can be activated from there. Also, you can open the VSVs for maintenance. The engine serial number entry well, this special function will allow you to feed the computer, the EEC, with the information about what your number is on board. Also for throttle reverser sync lock rigging for both side sleeves will be done through the special function feature. The throttle reverser actuator lock rigging for the lower and center on both sides. Throttle reverser will be available. Also, the throttle reverser directional control valve will be available. This information was not contained in what I presented on the Trent engine, as this manual is covering the entire engine, but it's going through more details. So it didn't refer that the mat can be used for checking and testing all of these components. Also, the air-driven actuator test can be done there. Ignition system test. You can fire the plugs, and it will tell you if it is working or not. So you actually don't really need to go and stand close to the engine when a test is conducting, because this will tell you. So the clapping sound will be heard maybe, but you can be on board. So also the reverse thrust lever interlock actuator test can be done there. The engine debris, I told you, and the EEC test as well. So that's a self-test that is produced inside the box. Probably there are no indications in the flight deck while the test is running. So it'll finish with a pass or fail signal. So it gives you a hint of what happens when you run one of these tests. For instance, say, and I think you might do this one over the time. You make this special with motoring function, so it makes that sure that the FMU opens staging valves, and this pressurizes all of the fuel manifolds for a leak check, and so on. So we're not going to go through all of them in detail, but there are a few of them. So this is another way it is presented in the mat. So once you get to chapter 71, you pick from this drop-down menu whichever test is required. And once it is selected, just press hit and continue, and it'll start. So special functions also will be presented in the same way, same chapter, but different drop-down menu, and you will find all these tests as well. So that was a general introduction for the general features of the cowlings, where to locate certain things. Also, the data plate is also accompanying each of the engines, so it'll tell you what model it is, what is the serial number, and what is the config and the thrust setting. And you can see as most of the engines are based on 6:1 bypass ratio layout. This is really powerful, so it comes up to 9:1. So it delivers a huge amount of air. One thing that makes the difference between the engines and as per the power setting, comes with refer to the dimensions. This engine was rated. One case is not there, but the initial rating was about 75 to 90,000 pounds. For some reason, it's not here. But what they do is they just increase the diameter dimensions, or they build larger. Well, not larger, but it's the longitudes of certain components are different. So they extend the sizes. So as they do that and they increase the diameter sizes, the power is increased. Oh, the thrust setting. This is telling us about the most powerful engine that is produced from the GE90 version, but the earlier models will start with a 75,000 pounds rating. So they were increasing the power as they enlarge the engine a little bit. So they increase measures. So finally, the later model, the GE90, came up to have over 115,000 pounds of power. So I missed it. So it's powerful, really powerful. All right. So as per the construction, before I go into this engine, let me show you the process of repairing this engine. It's very interesting to see. Let me mute my mic so you don't get disturbed by the echo.
Hello everyone, and welcome back to the Fluctus channel. The invention of the jet engine was a game changer for aviation. Not only did it drastically increase the speed at which aircraft could travel, but it also boosted their overall power. This allowed bigger planes to carry heavier loads across greater distances. Despite several jet and rocket-powered aircraft appearing during the Second World War, turbofans didn't become the preferred method of propulsion until the 1970s. Now, these air-breathing jets are incredibly advanced, which subsequently means they require regular maintenance by highly trained technicians. From the first test to the last flight, these jet engines are always under close supervision. Both commercial airliners and military jets have engine maintenance schedules. In most cases, this is determined by the number of flight hours it undergoes, ferrying passengers or cargo from one place to another. When an engine reaches its maintenance threshold, it is generally switched out for a newly repaired model. This process usually takes place at special maintenance hangars owned by major airlines, such as Southwest. In the case of modern jets like this Boeing 737, removing and replacing the engine can take anywhere from 4 to 7 hours. First, the cowling must be removed. This protects the sensitive parts of the engine from weather and debris. Dozens of attachments must be disconnected before the engine can be dropped onto the waiting dolly. The average 737 engine weighs around 2 tons or more, so it's imperative that they be handled very carefully. Once the inside of the cowling is inspected, a new or previously repaired engine is brought in carefully. Though underwing engines are by far the most common configuration for modern jet airliners, they are not the only option. This Boeing 727, for instance, features 3 engines in the tail section. Most models have Pratt & Whitney JT8D turbofan engines, which weigh more than 4,000 pounds. Since they are located too high up to be removed via dolly, replacements are generally done outside the hangar with the help of a crane. Once an engine is removed, it will typically go to a special repair facility located inside or adjacent to the main repair hangar. Here, it will undergo a complete overhaul, which typically includes individual part diagnostics and repair, module disassembly, and a variety of hole and component testing. The first step is what's known as a pulse line inspection. This is an electrical evaluation of the entire engine. Afterward, the engine is disassembled into various parts. Typically, repair shops have different specialists for each engine part. By removing the components, they can all work on the engine at the same time while ensuring maximum accuracy. They will also be carefully cleaned to remove corrosion, oil, and dirt. Components will be tested for cracks or other damage and replaced if necessary. The goal of this overhaul process is to get the engine back to like-new condition. Lastly, each part is inspected to make sure it meets the proper standards for being reintegrated with the engine. Even after the final reassembly, the engine must undergo extensive bench testing to ensure it will perform as expected. As with all other engines, proper lubrication is one of the most important parts of any turbofan maintenance. Depending on the part, some components of a jet engine can revolve at speeds of up to 20,000 RPM. Without lubrication, these could generate enough friction to create a fire in a fraction of a second. At GE Aerospace, specialized technicians look at many different sections of the engine to identify fan blades and pins that are too tight or otherwise malfunctioning. Lubrication is also a big part of this process, as many of these parts are intended to vibrate, but not loosen. By looking at the different colors on the pins, repair technicians can identify where metal was vibrating against metal without the benefit of a lubricant coating. Due to the low temperatures they encounter, contaminants in the air, and other chemical reactions, all parts of a jet engine are susceptible to damage and wear. Proper cleaning is the primary way maintenance technicians prevent this from happening. Major airline engine manufacturer Pratt & Whitney has started using a specialized engine wash system known as EcoPower. It directs atomized water directly into the engine while it is parked at the terminal, then collects the subsequent wastewater for purification and reuse. This time-saving solution allows for cleaning while the engine is still in use. And since it is fully self-contained, it keeps any and all chemicals from entering the environment. Cyclene has a similar engine cleaning system. It too is carried out directly at the gate and takes under 1 hour to complete. These sorts of jet engine cleanings are not only designed to reduce corrosion, but they can also improve overall fuel consumption, reduce performance deterioration, and extend the life of the engine. Cyclene engine wash happens about 2 to 4 times a year and uses pressurized hot water shot directly into the engine core. As with EcoPower, the resulting wastewater is captured for recycling. And where many engine washes can only be used in above freezing temperatures, Cyclene can add small amounts of glycol to the mixture to keep it from solidifying in the engine during cleaning. Over the years, engine manufacturers like Rolls-Royce have invested millions of man-hours into developing engines that are more efficient, more resistant to corrosion, and can last longer in between overhauls. The most recent culmination of these efforts is the Rolls-Royce Trent XWB. A high bypass turbofan specifically designed for the Airbus A350. This powerful engine is capable of putting out between 84,000 and 97,000 pounds of thrust, but is considered the most efficient aerospace engine currently in use. Each engine weighs nearly 4 tons and boasts a fan diameter of nearly 10 feet. assembly process is highly advanced.